Hi, in this video we are going to start implementing our eager primes algorithm, so let's get started. The edge is going to be the same, so in order to save some time I'm just going to, maybe I can paste it to, okay, the package name's going to eager primes. It's okay. Going to create a vertex, and I'm going to create a graph. I have never created a graph before, but in this tutorial I'm going to show you how to create a graph that's going to be store the list of vertices and the list of edges. Maybe it's a bit more consistent than storing it separately, the edges and the vertices. Maybe it's the best way, I'm not sure, it depends on you. Okay, so the vertex is going to have a private string name, going to have a minimal edge. Yes, a private visited, the private vertex, previous vertex, the private double min distance, and we set it to positive infinity. And of course it's going to store the adjacencies list. Public vertex. Because it's the eager version of the primes algorithm, we are going to store a reference, a minimal edge, and a minimal distance, because as we said earlier in the theoretical part, that we are going to update the heap from time to time when we discover that there's a shortest path from the given vertex to the minimal spanning tree, not to another vertex, it's very important, to the minimal spanning tree that consists of some vertices, of course, and edges. And that's what we are going to update, so we have to store reference to the minimum edge, and there will be a minimum distance. Okay, so this that name equal name, this is the adjacency list, is a new array list. Yes, and I'm not sure whether I have to use these, but min edge, name, previous vertex visited, min distance, the name. I don't have to create a getter and setter because I'm going to override the toString, and I'm going to return the name, and I'm going to modify the set adjacencies, because I'm going to rename it add neighbor as usual. Neighbor and edge list that add edge. Okay, I think that's all. Yes, is visited, set visited, string, and we should override. In this situation, we are not going to compare the edges. We are going to compare the vertices, and the comparator will work. Are going to decide what's the minimum according to the min distance. I mean, what's the minimum vertex? Comparable, of course, comparable and vertex. Okay. No. Okay. Okay, I think that we just have to return this, return double that compare this that min distance other vertex that get min distance. Okay, get min distance, yes. We are going to create our graph. Yes, it's going to store vertices and edge list. Public graph this that edge list new array list, this that vertex list is going to be a new array list as well. Okay, and we are going to implement our add edge method. It's going to get an edge, and if you remember in the previous tutorial we solved this problem with this not too clean code. We create forward edges and then the backward edges, and that's what we try to avoid because it's not too for me it's not too bad, but it's not a clean code in the way that I think if it would be a legacy code, I'm not sure that other people would understand why we adding these edges too. So we are going to hide it behind the class. Okay, so we are going to create a start vertex equal edge get start vertex target vertex equal edge get target vertex, this that vertex list that get, it's not going to be nice, vertex list that index of start vertex that add neighbor new edge start vertex, the weight is going to be edge get weight, and start vertex target vertex. Okay, so we set the first edge, the forward edge or whatever we call it, and we have to give it a backward edge too. So vertex list get target, and I think that we just have to swap these. So here will be the target vertex and here will be the start vertex. And then when we call this method and add a new edge, it's going to add one forward edge and one backward edge, so it's going to be much nicer. Okay, so in the next video we are going to implement the concrete algorithm. Thanks for watching.